Hello Hackaday fans and judges. Today I'd like to show off my entry for the Hackaday prize, the Polymerase chain reactor, and its little brother, the $5 Polymerase chain reactor. This project was started quite late in the competition, but after several rounds of design and development, I've finally come up with a machine that can almost fit in your pocket. It uses cheap off-the-shelf components, it's open source, and it works really nicely. This is a regular PCR machine. It works by heating and cooling this big block of aluminium in which we have our samples. All this requires an interface to control and program the device, huge fan so it's really noisy, and it uses heaps of power. And this is the Polymerase chain reactor. Now the innovation is, instead of having this expensive and huge heating and cooling elements, we just have 3 PID-controlled heaters. The first stage is our denaturation at about 95 degrees. The second is our annealing at about 55 to 65 degrees. And the final is our elongation zone, where our DNA is actually copied, and that happens at about 72 degrees. All we do is we put our sample into a cheap piece of Teflon tubing, held together by some silicon tubing, and mount it into the device like so. Because the denaturation temperature is so much higher than the other 2 zones, convection forces the liquid upwards and it moves them in a loop. This happens pretty quickly, so 30 rounds of PCR takes only about 30 minutes as opposed to about an hour and a half on a machine like this. On the back of the Polymerase chain reactor, we have our USB control, a power input, a power select switch, a reset switch for reprogramming the device, and inside is a Bluetooth dongle which lets us connect to the computer. The device is so much cheaper because there isn't an expensive interface. Everything's done on the computer over the Bluetooth connection. This is the device that you can build at home and help join in on the biotech revolution. With it you can do really amazing experiments. You can clone DNA, you can do recombinant DNA experiments, and today I'm going to show you just one of the small things you can do with a machine like this that I'll be doing on the $5 Polymerase reactor. Has this ever happened to you? You put something that belongs to you in the communal fridge, but when you get back, you find someone's been helping themselves to your stuff. Unless you've got surveillance cameras set up, or they left their fingerprints on this bottle, you've got no chance of figuring out who took your drink. Unless they left their DNA fingerprints on there. We can take a tiny sample from a crime scene, make millions of copies, and then compare that to records in a database to identify people. We'll be taking a sample of DNA from the crime scene and amplifying it in the Polymerase chain reactor. Potential suspect's DNA is collected from saliva. Then the DNA is extracted with a standard kit. It takes about an hour or so and doesn't require any special equipment. We have to mix together our PCR reaction. Now it's time to mix it with our sample of DNA from the crime scene. We take some thin-walled Teflon tube and we cut a length that's about 18 centimeters long. We also take some silicon tubing that's about 1 centimeter long. You can quite easily fit the Teflon tubing into the silicon tubing. You just take the PCR reaction mixture, stick the tip into the stretchy silicon tubing, and just squeeze it in until the reaction mixture is just starting to squirt out the top of the other tube. Use that droplet to push the ends together and not let a bubble get into the silicon tube ring. With our DNA sample now ready, we can mount it into the Polymerase chain reactor and then connect to the serial port. After half an hour, we can turn off our power supply and take our sample out. Then we load our samples into our gel. We also load up the suspect's DNA, and now it's time to run the gel. We end up with bands for each suspect. Each suspect has 2 bands, although they can overlap. The DNA from the crime scene only matches one of the samples from the suspects, and that happens to be me. So the mystery's been solved. I really hope that you like what you've seen. I look forward to showing you even more updates, a more professional product, and some really crazy experiments when I make it to the finals round. Thanks very much for your time.